Hi everyone, my name is Ajit Raza and today we'll talk about basics of C#.NET programming part number 5. Today I'm going to take you to some advanced level. We'll talk about more about variables and then we will go for conversions, enumerations, structs and arrays. Let's talk about why we are talking about the variables more today. So we have talked a lot about variables, but let's take things to some advanced level, which I have already discussed. And we are going to talk about the type conversions. These are the type conventions that were talked about in the previous tutorials, and today we'll talk about the type conversions. So in this one, you convert values from one data type to another one, and after that we will talk about the enumerations, variable types that have a user-defined discrete set of possible values that can be used in a human-readable way. After that come the structures, also known as the structs, composite type of variable made up of a user-defined set of the other variable types are called the structs or the structures, basically written as the structs. After that, we will talk about a wide variety of arrays and how we use them, because it holds multiple variables of one single type, allowing the index access to the individual values. So we will talk about the arrays, how arrays form, and what are the necessity of these arrays, and how we are going to use in our project, in our tutorials, now in our coding, etc. So let's talk about the type conversions here. First of all, the meaning of the variable is determined by how this data is interpreted. The simplest example of this is the char type. The type represents a character in Unicode character set using the number. Number is stored in the same way as the ushort, which is basically only ranging the numbers from 0 to 665,535, and it stores none of the negative values in it. So this implies that even if it were possible to place a sequence of bits from one variable into a variable of a different type, perhaps they use the same amount of storage, or perhaps the target type has enough storage space to include all the source bits. Instead of one-to-one mapping of these bits from one variable to the another variable, you need to use type conversion on the data, and this type conversion takes two forms basically. One is the implicit conversions and the second one is the explicit conversion. Let's talk about the implicit conversions here. Basically, it is also read as or spoken as implicit or implicit. You can pronounce it as whether you are easy to pronounce it. So let's talk about it. Conversion from type A, let's suppose, to type B is possible in all circumstances, and the rules for performing the conversion are simple enough for you to trust in the compiler. And implicit conversions require no work on your part and no additional code. Let's consider a code here like variable 1 equals to the variable 2. This assignment may involve an implicit conversion of the type of variable 2 can be implicitly converted into the type of variable 1. However, it could just as easily involve two variables with the same type, in which case no implicit conversion is necessary. For example, the values of ushort and char are effectively interchangeable because both store a number between 0 and 65,535. So you can convert values between these types implicitly, as demonstrated by the following code. Let's suppose that we declare a variable var1 in ushort and var2 in char. So char, and we initialize variable 2 and a value of a, which is a string, and let's initialize variable 1 that is equals to the variable 2, and when we print them out, so variable 2 is placed in the variable 1, so variable 2's value will be placed in the variable 1, but there's a slight difference. Whereas the variable 1 will be declared in the ushort data type. So when we have initialized that variable 1 equals to the variable 2, but when it comes to the result output on the console screen, the difference will be totally different. There you will see as like I have declared initialized a value in the variable2, which is a, and I have initialized a variable1 equals to the variable2, which is a. But I have declared a variable1 a data type, which is known as the ushort type. So when I will run this program on the console screen, it will show me a 97 Unicode character. Basically, it is also known as the hexadecimal character or UTF-8 coding character conventions behind this computer program. Basically, this is how our alphabets are being stored in our computer. So through this thing, it will recognize how values are stored and how these things work. It's the conversion. We type an alphabet L, and the, the the system in our computer or the compiler reads that L and then converts it into the binary or hexadecimal system, and then after that it shows us the computer reads that command, and then again the compiler processes it and shows us on the display that it is the L character that we have typed. This process is done in a blink of an eye. It is so fast that it is done in 100th part of the second, or you can say as the 1000th part of the second. Is so much fast that you can't even measure the speed, how much fastly these processes are doing in the computer system. So I have made up a table for you guys. Basically, these are the types which can easily be converted to other data types, and there are no errors and omissions that are coming out of these types. So these are the things that come out when you convert from byte to short. You can convert easily byte to short, u short, int, u int, long, u long, float, double, decimal without any errors or omission. You can easily convert as byte into short, int, ill, etc., and so on. So don't worry, you don't need to learn this table by heart, because it's quite easy to work out which conversions the compiler can do implicitly or implicitly. So let's move on to the explicit conversions. As the name suggests, an explicit conversions occurs when you explicitly ask the compiler to convert a value from one data type to another. Right, we have to ask the compiler to convert one data type to the another. These conversions require extra code, and the format of this code may vary depending on the exact conversion method. For example, the following modification to the code from the last section attempts to convert a short value into a byte. Like we declare a value variable var1 a byte data type, and then we declare and initialize variable to a short data type and initialize a value of 7. But after that we initialize variable1 equals to the variable2, and then we write but this writing will show us an error on the log section between the on the Visual Studio command Visual Studio IDE. If you attempt to compile, as it is stated that if you attempt to compile the preceding code, you will receive the following error, which is the basically cannot implicitly convert short to byte, and explicit conversion exists. So it is saying that you can't convert from byte to short. Can we convert bytes to short? No, there is no thing that you can convert. You can convert to byte to short, but it is not safe here. We have to use something like this one. We have to declare a byte. We are converting from byte to short, so we have to use that byte is converted into the short variable. Like byte is the variable 1 is a byte data type, and variable 2 is of a short data type. So when we are initializing it, we are basically telling that variable 1 only equals when we have to multiply the variable 2, which is of short data type, into the byte data type. So and it is showing that are you missing a cast. So basically cast is a variable or a data type or a method that we are missing here. So this is how it is done when it comes to the C# in converting of the methods explicitly. So most of the programmers and coders out there use the implicit conversion or conversion method instead of using the explicit, because it contains a lot of sometimes errors. Sometimes we also forget to convert from one data type to the another data type, and that is a much more pain when it comes to the writing down 1,000 line of codes, and it is so much headache when it comes an error like that. Can't even point it out because there's so much code and so much lines of code, and sometimes due to lack of time we will definitely use in our future tutorials the implicit conversions instead of the explicit conversions. So let's talk about the complex variable types. Um, Here we will talk about uh, three slightly more complex sorts of variables, which are enumerations, often referred as enum, structs, occasionally referred to as structures, and arrays. Let's start with the enumerations. Each of these types you have seen so far, except for string, has clearly defined set of allowed values. Admittedly, this set is so large in type, such as double, that it can practically be considered a continuum. So basically, continuum it means that we are practically continuing our code in that set in that manner, but it is a fixed set. Nevertheless, definitely we are dealing with animations in a very fixed amount of limited amount of sources. So in this situation, like animations can be very useful. So animations do exactly what you want in this orientation type. They allow the definition of a type that can take one of a finite set of values that you can supply. What you need to do is create your animation type called orientation that can take one or four possible values. Like I will type enum and type any name, a variable, and then I will store n values inside it. Then you can declare variables of this new type as follows. Then I will type that name and declare a variable, and the values will be stored inside it. As we are in this way, we are going to make so much new data types and gonna use them and fetch those data inside those data types. And this is how we assign the values in those variables. Animations have an underlying type used for the storage. Each of the values that an animation type can take is stored as a value of this underlying type, which by default is int. Int basically here is integer. So this is how the enumeration is done. And let's talk about the structures or the structs. The struct short for the structure is just that structs are data structures composed of several pieces of data, possibly of different types. They enable you to define your types of variables based on the structure. For example, suppose that you want to store the route of to a location from a starting point where the route consists of a different direction and a distance in mile. For simplicity, you can assume that the direction in one of the compass points such that it can be represented using the orientation enumeration from the last section, and the distance in miles can be represented as a double type. You could use two separate variables for this using code you have seen already. This is basically orientation in Structs. It is a declaration of different variables, and the double is that one. So there is nothing wrong with these using two variables like this, but it is for simpler, especially where multiple routes are required to store this information in one place. To allow the code that calls for the struct to access the struct's data members, you use the keyword public for the accessibility. For example, let's take an example like struct root. Basically, struct, we are using it and then defining the variable inside it. We are going to use a public orientation and a public double. Basically, we are going to declare these things in our future tutorial when we want to access multiple variable data types within different classes. And in OOP structure, definitely we will discuss this a lot. Once you have a struct type defined, you use it by defining variables of new types that like root, my root, definitely. And that was it for the structs. Let's talk about the arrays. um, Arrays is a very hot thing, or you can say a very important thing in the programming. You will see so much work in the arrays. Even like hackers use so much part of the arrays to increase the value of their attack, or decrease the value of their attack in the payload they make about virus and malwares they execute in different and malicious in and many kinds of malicious software. Basically, the basic work is of arrays behind those algorithms and everything. So arrays is very important, and we are going to cover so much in it in our next very because this topic or article will be divided into 2 to 3 volumes, like volume 1, volume 2, volume 3, because we are going to extensively discuss about the arrays here. And arrays, I'm believing, guys, arrays is the most important thing in the programming and the making of the algorithm. Once you have understood how arrays are made, then you will understand how to code your own software easily and to increase or decrease the value. And if you are on the security side, which is as do I am, like if you are an ethical hacker or a black hat hacker or gray hat hacker, so you will use arrays in lots of your programs and develop your programs in different ways. So let's see. All the types you have seen so far have one thing in common. Each of them stores a single value or a single set of values. In the case of structs, sometimes in situations where you want to store a lot of data, this isn't very convenient. You may want to store several values of the same type at the same time without having any to use a different variable for each value. Like, for example, suppose you want to perform some processing that involves the names of all your friends. You should use simple string variables as follows, like string friend name 1 and which dot Anthony, and string friend name 2 is Kevin Holton, and string friend name 3 is Shan Lively. So, but this looks like it will require a lot of effort, especially because you need to write different codes to process each variable. We couldn't, for example, iterate through this list of strings in a loop. The alternative to is to use an array. So arrays are index lists of variables stored in a single array type variable. For example, you might have an array called friend names that stores the 3 names in the preceding string of variables. You can access individual members of the array by specifying their index in square brackets as shown here. Friend and the square bracket and the index, we will write index which is index which 0, 1 or 2 or 3. Basically, computer program especially remember that the counting starts from 0, and 0 has a value as a memory or a data inside it. So never ever start with 1. So index is simply an integer starting with the 0 definitely for the first entry, using 1 for the second, and so on. This means that you can go through the entries using a loop. So let's take an example like integer I, declaration an I as an integer, and we are then going it through a loop of for in which we have set a value of 0 to 2. Basically, these are 4 values, but we are round off to the 3. So I is smaller than 3, then we will start from 0 to 2, not to the 3, because it is only indicating that I is smaller than 3. So we will stop at 2, and the compiler will not go to the fourth value, which is 3. So here we will write the console write line name with the index and the I, and the friend's name with the index, in which index it will fall 0, 1, or 2 or 3, and it will print out that name on the console screen. So this is how it is done. So arrays have a single base type that is individual entries in array, and array are all of the same types. This friend name arrays has a base type of string because it is intended for storing string variables. Arrays entries are often referred to as elements. Basically, these arrays entries are also known as the elements in the arrays blocks. So arrays must be initialized before you have access to them. You can't just access or assign values to the arrays elements like this. So that I have declared my int array, and then I'm also I have declared array with the data type. So this is not the proper way. Or I have a variable of my int array which has an index of 10 values, and it is equal to 5. No, this is not how the properly we initialize or declare them. We will have to initialize like this one. Like arrays can be initialized in two ways. You either specify the complete contents of the array in a literal form, which is this one, or specify the size of the array and use the new keyword to initialize all the array elements. Like int and my int, I have declared a variable and then declare 5 elements inside it, and this is the literal form, and this is how we specify a number inside that integer data type, that how much index we want. And this is how we declare it, that initialize it, that new int is which we will put the values inside it through the console screen, which is equals to the 5. Here you use the new keyword to explicitly initialize the arrays. Basically we will initialize that value through the code or through the console screen, that we will use through the console dot read line or the read key or whatever the command there are that you have that I have listed in the previous tutorials and you have seen, and a constant value to define the size, basically. So this method results in all the array members being assigned a default value, which is 0 for numeric types. And you can also use non-constant variables for this initialization. And which are the non-constant variables are basically these are the array size, and besides that, you can combine these two methods of initialization if you want. Like I have declared initialized a variable an array size of a constant, because through that I could initialize to the console screen or write a code how much arrays I want, how much indexes of arrays or elements of arrays I want inside the arrays. So besides, this is how we can combine if you initialize two methods. So int my new int is indexed 5, and these are the elements that I want to initialize inside it. So this method, the sizes must match. You can't, for example, write the following, like I have initialized a value of 10 inside an array, and I am entering the elements inside it like 5. This is not the way. We will get the so much errors. Let's talk about some other types of arrays too today, like multi-dimensional arrays, and that's it. There are two types of arrays you will mostly hear, or you will mostly see on the internet, like 2D array, 1D array, 3D arrays, 4D arrays. Basically, these are the dimensions of the arrays. Like I am using one-dimensional array, two-dimensional array, three-dimensional array, four-dimensional array, and so on. And the number is so much big that you can add so much arrays in your program and whatever you are building at that time. So let's talk about the multi-dimensional array, which is simply one that uses multiple indices to access its elements. For example, basically it is talking about multiple indices, that multiple elements that we can store and indexes that we are going to store in that array block of and access all the elements through those indices and indexes. For example, suppose you want to plot the height of a hill against the position measured. You might specify a position using two coordinates, which is x and y. So you want to use these coordinates and indices, such as an array called room height, or would store the height at each pair of the coordinate. This involves using multi-dimensional arrays. A two-dimensional array, such as the declare as follows. Basically base type, here it is, and this is two-dimensional. So why it is two-dimensional? Because we are using a base type and a name and a single this dimension indice of the array can use it is called the two dimensional because it is storing base type and the name and the two elements inside it. So after that comes the dimensions, and we can use more commas. So for more dimensions we are more using more commas. So this is the 2 into the raised power n, which is 3, and we can use it is the 6d, 6 dimension of the array. So this would declare a 4-dimensional array, and assigning values also uses similar syntax with the comma separating sizes. Declaring and initializing the 2-dimensional array room height with the base of height type of double and x size of 3 and y size of 4 requires the following. So this is how it is done. So double room and new double 3 4. Alternatively, you can use literal values for the initial assignment. Here you nested blocks of the curly braces separated by the commas. Like I want the 4-dimensional, so 2-dimensional, so I'm going to index some values inside it: 1 2 3 4 2 3 4 5 and 3 4 5 6. This array has the same dimension as the previous one, that is 3 rows and 4 columns. Definitely 3 rows and the 4 columns, basically 4 columns and 3 rows, you can see that. So it is basically written as like this thing. So let me clear you out. This is how it is done. So you will see 3 rows and 4 columns. So this is how it is coded. So let's not be so fast here. Okay, 4 columns by providing literal values. These dimensions are defined implicitly. So to access individual elements of a multi-dimensional array, you simply specify the indices separated by the commas, like room height and 2 and the 1 dice and 1. So this is 2-dimensional array. So that's it for today, guys. I hope you have enjoyed a lot today learning about the enumeration, structs, and arrays. We will code all of these in our very second tutorial, because today's target was only to inculcate all these concepts into your minds. We will do some hardcore practice in our next tutorials, and will dive deep into this amazing world of more about the variables. So that's it from my side. I hope you have really enjoyed. Stay tuned for the further tutorials. Allah Hafiz.